If you suspect that two circuits in your home are connected, causing one breaker to trip when the other is energized, there are methods to identify the point of connection more efficiently than simply going room by room. Two approaches are commonly used: firstly, using a voltage detector, and secondly, using a clamp meter or circuit tracer. Let's explore each of these in detail. When using a voltage detector, the initial step is to turn off both circuit breakers involved. This is crucial for safety. Next, use a non-contact voltage detector to check each of the wires in the two circuits in question. The voltage detector will alert you if any of the wires are energized. If a wire is found to have voltage present even with the breakers off, it indicates that it is connected to the energized circuit. The next step involves tracing the wires back through the electrical boxes, carefully following the path of the wire that indicated voltage. This process helps you to pinpoint the location where the two hot wires are touching or improperly connected. Alternatively, a clamp meter or circuit tracer can be employed. Again, begin by turning off both circuit breakers. Then, use a clamp meter or a circuit tracer to inject a signal into one of the circuits. Circuit tracers typically have a transmitter that sends a signal along the wire and a receiver that detects the signal. Follow the signal through the house using the receiver. The goal is to identify where the signal from the injected circuit appears on the other circuit. The point where the signal is detected on the second circuit indicates the location where the two hot wires are connected. These methods can significantly reduce the time and effort required to find the source of the short circuit. Always remember to prioritize safety when working with electrical systems. If you are not comfortable performing these tasks, it is best to consult a qualified electrician. Before undertaking any electrical work, it's crucial to understand basic electrical safety principles. Firstly, always turn off the power to the circuit you are working on at the breaker panel. Secondly, use appropriate personal protective equipment, including safety glasses and insulated gloves. Thirdly, never work on electrical systems in damp or wet conditions. Fourthly, always double-check your work with a voltage tester before restoring power to the circuit. When troubleshooting electrical issues, it's helpful to have a basic understanding of how electrical circuits work. In a standard 120-volt circuit, you have a hot wire, a neutral wire, and a ground wire. The hot wire carries the electrical current from the breaker panel to the outlet or device. The neutral wire returns the current back to the breaker panel, completing the circuit. The ground wire provides a path for stray current to return to the ground, preventing electrical shock. A short circuit occurs when the hot wire comes into contact with the neutral wire or the ground wire, bypassing the intended load. This causes a large amount of current to flow through the circuit, tripping the breaker. Common causes of short circuits include damaged wiring, loose connections, and faulty devices. When troubleshooting a short circuit, it's important to systematically check each component of the circuit. Start by inspecting the outlets, switches, and light fixtures for any signs of damage or loose connections. If you find any problems, repair or replace the affected component. If you are unable to find the source of the short circuit, it's best to consult a qualified electrician. Attempting to repair electrical systems without the proper knowledge and experience can be dangerous. When working with electrical wires, it's important to use the correct size and type of wire for the application. The size of the wire is determined by the amount of current it needs to carry. The type of wire is determined by the environment in which it will be used. For example, when running wires in a conduit, you should use THHN wire, which is designed for use in dry locations. When running wires outdoors, you should use UF wire, which is designed for use in wet locations. It's also important to use the correct type of connectors for the wires you are using. There are different types of connectors for different types of wires and different applications. Using the wrong type of connector can result in a loose connection, which can cause a short circuit or a fire. When making electrical connections, it's important to strip the wires properly. Use a wire stripper to remove the insulation from the end of the wire without damaging the conductor. The amount of insulation to remove will depend on the type of connector you are using. After stripping the wires, twist the strands together to ensure a good connection. When connecting wires to a screw terminal, wrap the wire around the screw in a clockwise direction. This will ensure that the wire is pulled tighter as the screw is tightened. When connecting wires to a push-in connector, insert the wire fully into the connector. Be sure to use the correct size wire for the connector. When working with electrical systems, it's important to follow the National Electrical Code, or NEC. The NEC is a set of standards for electrical wiring and equipment. It's designed to ensure the safety of people and property. The NEC is updated every 3 years, so it's important to stay up to date on the latest changes. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It also includes specific requirements for different types of occupancies, such as residential, commercial, and industrial. One important aspect of the NEC is overcurrent protection. Overcurrent protection is designed to protect electrical circuits from damage caused by excessive current flow. Overcurrent protection devices include circuit breakers and fuses. Circuit breakers are designed to trip when the current flow exceeds a certain level. Fuses are designed to melt and break the circuit when the current flow exceeds a certain level. The size of the circuit breaker or fuse should be matched to the size of the wire in the circuit. If the circuit breaker or fuse is too large, it will not protect the circuit from damage. If the circuit breaker or fuse is too small, it will trip or blow unnecessarily. Another important aspect of the NEC is grounding. Grounding is designed to provide a path for stray current to return to the ground, preventing electrical shock. The grounding system includes a grounding electrode, which is typically a ground rod or a metal water pipe. The grounding electrode is connected to the electrical panel and to all of the metal parts of the electrical system. When a fault occurs in the electrical system, the straight current will flow through the grounding system to the ground, tripping the circuit breaker and preventing electrical shock. The NEC also includes requirements for equipment installation. Electrical equipment must be installed in accordance with the manufacturer's instructions. This includes requirements for mounting, wiring, and ventilation. Electrical equipment should also be inspected regularly to ensure that it is in good working condition. If you are planning to do any electrical work in your home, it's important to get a permit from your local building department. A permit will ensure that the work is done in accordance with the NEC and that it is inspected by a qualified inspector. This will help to ensure the safety of your home and your family. When choosing an electrician, it's important to choose someone who is licensed and insured. A licensed electrician has met the requirements of your state or local government to perform electrical work. An insured electrician has insurance to protect you from liability if something goes wrong. It's also a good idea to get references from previous customers before hiring an electrician. When you get a quote from an electrician, be sure to get it in writing. The quote should include a detailed description of the work to be done and the cost of the materials and labor. Be sure to ask the electrician if there are any additional costs that may be incurred during the project. Before starting any electrical work, be sure to turn off the power to the circuit at the breaker panel. This will help to prevent electrical shock. Use a voltage tester to verify that the power is off before touching any wires. Wear appropriate personal protective equipment, including safety glasses and insulated gloves. Never work on electrical systems in damp or wet conditions. If you are not comfortable performing electrical work, it's best to consult a qualified electrician. Attempting to repair electrical systems without the proper knowledge and experience can be dangerous. Remember to always prioritize safety when working with electricity. If you are unsure about anything, consult a qualified electrician. This information is for educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrician before performing any electrical work. The NEC, National Electrical Code, is a comprehensive set of standards, and familiarity with at least its basic principles is helpful. The NEC outlines safe practices for electrical installations. For example, Article 210 covers branch circuits, detailing requirements for outlets, lighting, and appliance circuits. Article 250 focuses on grounding and bonding, essential for safety. Article 300 addresses wiring methods and materials. These articles contain numerous specific rules, such as conductor sizing based on ampacity, proper overcurrent protection, and approved wiring methods for different environments. Let's consider a specific example. Suppose you are installing a new 20 amp circuit for a kitchen appliance. The NEC specifies that you must use 12 American wire gauge copper wire as per NEC table 310.15b16 to handle the 20 amps current. You must also install a 20 amp circuit breaker to protect the circuit from overloads. The receptacle must be a grounded type, and the wiring must be installed in accordance with approved wiring methods, such as using non-metallic sheath cable or Romex for dry locations. It's important to consult the specific NEC articles and tables to ensure that your electrical work complies with the code. Ignoring the NEC can lead to unsafe installations, electrical fires, and potential legal liabilities. Even seemingly minor details, such as the proper way to splice wires or the correct type of conduit to use, are covered in the NEC. Many online resources and training programs can help you understand the NEC. It is a complex document, but understanding its basic principles is essential for anyone working with electrical systems. Remember, when in doubt, consult a qualified electrician.